Hello, everyone. Welcome to CETV, hosted by Cloud on Air, where we host live webinars every Tuesday. Today, we are going to be talking about Networking 103. My name is Stephanie Wong, developer advocate for Google Cloud, and today I'm joined by Binal Shah, who is a networking specialist and customer engineer for Google Cloud. Last time, we spent a couple sessions with Ryan Frisbel, who's also on her team, covering Networking 101 and 102, where we talked about VPCs, VPC peering. We also covered interconnect, routing, shared VPCs. So we're going to continue speaking on that topic, but diving a little bit deeper into security and best practices there. So before we get started, I also wanted to mention that you all have the opportunity to ask questions throughout the session. We will have live Googlers answering those on the platform. And at the end, we'll save some time for you all to ask questions as well. We'll collect them, and then we'll jump back on and answer them at the end. So without further ado, take it away.
Thank you, Stephanie. Hi, everyone. I am Binal Shah, a networking specialist at Google. I work with our customers with their networking requirements and architecture on Google Cloud. So today we're going to talk about security. Network security is a big part of infrastructure design. Whether you're deploying your environment on-prem or in cloud, right? There is a requirement to secure your resources. Today, we will talk about some of the best practices and how you secure an environment in Google Cloud. So first thing you will start with, whenever you start deploying a project, first thing you'll do is spin up a VPC. By definition, VPC is an isolated domain where no one has access to it unless you allow access. So as you're adding users and assigning them IAM roles, a good practice is to follow the principle of least privilege. So understand the user's function and then only allow as much access the user needs to do their job. This way, you reduce errors due to misconfiguration and thereby reduce downtime.
So this is relating to IAM policies, identity and access management, permissions and roles.
That's correct. Okay. And then you start deploying instances in your VPC. At that point, you want to restrict flows to your instances. That's how you protect your instances. For this, you use firewall rules. We'll talk a little bit more about firewall rules, but this is a good time before you start spinning up your instances, right? It's a good time to sit down with your application team and network and security teams together to identify what flows the application needs, right? You do want to make sure the application runs, but at the same time, you want to protect your instances from unwanted traffic. All right, now you have your VPC set up. The next thing you want to do is connect back to on-prem. So we have a few ways we are able to do this. So let's say you want to talk to your Google services like G Suite. So in this case, from on-prem to G Suite, you can deploy direct peering, where you peer your router with one of Google's routers in the closest peering location. And then Google is your next hop for all the Google services traffic. This way, given that Google is your next hop, you are not going over the internet, crossing multiple ASNs, so that reduces your latency and gives you better performance. Now, you also want to have connectivity between your servers, and you want private IP connectivity between this, right? Couple options, right? You can do Cloud VPN. Cloud VPN is our site-to-site IPsec VPN. The traffic goes over the internet, but it is fully encrypted, so it is still secure. Cloud VPN is a good solution when you have lower bandwidth requirement, and it's very quick to set up and get going. Now, we do have customers. Sometimes they do not want to let their traffic go over the internet at all. Or they have very large volumes of traffic. So we're talking about tens of gigs of data, right? So for this, we have dedicated interconnect options. So dedicated interconnect, again, you connect your on-prem and meet us at one of the co-locations and connect directly to Google Cloud. From there, you pull a VLAN attachment and cloud router in your VPC. So you have connectivity directly into your VPC. And then between the cloud router and your on-prem router, you run link local BGP to exchange routes.
So again, this is internal communication across.
That is internal communication. So your servers will talk using private IPs. So 10.10.10.1 can talk to 192.168, for example. Great. So we have the connectivity set up. Now, oftentimes we see, right, customers come in, they have an architecture on-prem, and they're using a lot of vendor solutions like Next-Gen Firewall, IDS, IPS, and they would like to carry that architecture into Google Cloud, right? By way of our partner solutions, they are able to do that. So they can work with their partners and deploy the same solutions in their Google Cloud environment.
Okay, so just to reiterate, you are able to use third-party appliances and bring them over to GCP.
Absolutely.
That way we're able to kind of meet you where you are. You can continue to re-architect in the same way.
Yes. Always look at what Google offers. And then, like I said, customers have their solutions. They also want to work with the same vendors that they are. Then we have that capability in our marketplace. You can find those vendors. So now you deployed your applications in Google Cloud, and you want to scale. So you're going to front it with a load balancer. So Google's global load balancers provide you edge protection from L3 and L4 attacks. So Google's global load balancer also uses any cast IP. That is one IP advertised globally. So you can front end your application with just one IP. And you remember the Google's global infrastructure, right? Just by the way of the infrastructure that we have, customers are able to have backends in different regions, behind their load balancers. So what this does is it brings the workloads closer to the user. So your end user will see less latency and hence improved performance, right?
You mentioned that this global load balancer offers L3, L4 protection. Are there any other additional ways that you're able to protect your application?
Absolutely. So we have a product called Cloud Armor, which integrates with the load balancer and provides additional protection from DDoS and for the applications, right? In addition, we also have, again, partner solutions that customers can use. Again, customers can be already using it, and they want more protection for their specific protection for their application, then they are still these solutions are still available to use. Awesome. So now let's take a little bit deeper dive into some of these solutions, right? So when you spin up instances in your VPC, first thing you're going to do is give it a private IP, and then you have an option to add a public IP. Once you assign a public IP to an instance, remember, this instance is accessible from the rest of the world. So if your instance does not need to be reachable from the outside, you don't need to add a public IP. This way, you just reduce the attack surface for the instance. Now, there are cases where your instance can have a private IP, but it still needs to go out, right? It needs to get updates, etc. So it will need outbound communication. This we enable using CloudNAT. So CloudNAT is Google's software-defined solution. So this is not a VM. This is not an appliance. It's just a scalable software solution. It is regional. So you add this CloudNAT in each region. Then all the subnets within that region can use this NAT to go out. You also have control over if you only wanted specific subnets to go out. You may still not want some instances to go out at all. So you do have that kind of control.
So we also have customers who might have been used to using other architectural setups like Bastion hosts or proxies. In addition to having this CloudNAT option, when do you recommend each kind of use case?
Good question, Stephanie. So let's say I have my instances and I need to SSH into these, right? I don't want to open SSH to the entire world, right? So I know who needs to access, so I can allow just my corporate IPs to access. But usually what you do, this is where you use a Bastion host, right? So you keep one Bastion host, you allow access to that host, and these instances can only be accessed from the Bastion host. That way, that is a lot more controlled access.
Okay, right.
Right? And you can also use proxies to go out. A lot of customers use that. One more thing I wanted to note. So if you wanted to talk to Google services, so your instances wanted to reach Google services like cloud storage or BigQuery, they can do that using private IP. So you don't need to add a public IP just to access Google services.
Okay, that's great.
And that's pretty neat.
Right.
Yes. Awesome. Thank you. So the next step is you want to restrict flows to your instance, right? You want to protect your instances. We have Google's distributed firewalls that will help with this. How are they different, though, right? It's important to understand. On the left side, you see is an architecture that you traditionally see on-prem, right? So the firewalls are closer to the edge, all traffic comes in and hits these firewalls filtered through these firewalls. Sometimes these firewalls can be a choking point, but more importantly, once the traffic leaves the firewall, there is little control, no easy way to control communication between instances. So on Google Cloud, our firewall is a distributed firewall. And the way it works is when a packet is trying to reach an instance, the firewall rules are checked at that time. And only if there's a firewall rule that allows this traffic to the instance will that packet be allowed. If there's no firewall rule, the packet does not reach the instance. So as you see in the diagram, you can control communication north-south as well as east-west. So if you look at this diagram, there are instances with a tag called red tag and some instances with the blue tag. So when I add my firewall rule, my rule will look like source will be red tag, VMs with red tag, and destination will be blue tags. This is a neat way to group together similar function VMs. What happens is you now enabled east-west communication. Another option is to use service accounts on a VM. That's a bit more secure than tags, because with tags, it needs compute admin. It still needs compute admin privilege to change the tag, but it can be done while the VM is running. So depending on your use case, you have options.
I see. And for the use case of those who have projects in different regions or just have shared VPC and they want internal communication across multiple projects, how would you set up firewalls or communication across them?
Yeah, so a firewall rules is global within a VPC, right? So if I have one VPC and have multiple regions, it's still going to be one firewall rules table. You add your rules there. Now you mentioned the case of shared VPC. Mm-hmm. So in shared VPC case, there's one VPC in a host project, and now you are connecting a lot of service projects and sharing these subnets with the different service projects. So it's a valid point. You want to control communication between these projects, right? So you still go back in the host project and in the shared VPC and add firewall rules there. Okay. So shared VPC is still like a VPC. You have the ability to share your subnets down. So I would say subnet 1 shared with service project 1 and subnet 2 shared with service project 2. I will put a rule, so much communication on these ports, these protocols to these VMs is allowed between these two projects. Cool. By default, all ingress will be denied. So only allow, again, another principle is only allow access that you need to. By default, egress is all allowed, but there may be cases where customers do want to restrict that. So you have the ability to do that. And here is an example of how firewall rules can work together in Google Cloud. Like we said before you deploy applications, it's a very good idea to know the flows. Couple things, just from experience, right? Troubleshooting gets easier. You have a blueprint. Anytime an application, there's issue with the communication, you can look at the blueprint and validate the flows are allowed. Firewall rules are not the cause of downtime. The other thing is, firewall rules are a finite resource, so it is important to plan them before you start adding. And we talked about tags. I'm going to just show you an example how you can reduce the number of firewall rules just using tags. So in this diagram, right, on the right is my management subnet. There are my management VMs that will have access to all the instances, right? So if you look at the second rule below that I have written, my source is going to be management subnet. Then my destination is all instances. So actually from the drop down in the console, you can say all instances in the network. And then you allow specific ports. In this case, I want to allow SSH, and then I also want to allow ICMP. So now the next thing is I have web servers, right? I will group all the web servers together based on function and add a tag www. And then these web servers want to talk to app servers over specific ports. Then I will add a rule saying all VMs with the tag www, those are my source, can access VMs with the tag app. And then the access should be allowed for these ports and these protocols, in this case, HTTP and HTTPS.
So outside of just the limitation of firewall rules, Are there other reasons why tagging in these firewall rules would be a benefit?
Yeah, tagging definitely helps you group together similar instances. So another application comes on board and you have the same rules. You already allowed it. You just have to give the right tag to the instances, right? So the rule is already there. You can reuse. And remember, firewall rules are a finite resource.
Yeah.
So you want to make sure you efficiently plan your firewall rules.
Right.
Firewall rules are also important between VPC peerings. So it's critical that you allow only the flows that you want. Just a little bit on VPC peering, right? VPC peering within Google Cloud, our VPC is global. So if within a VPC you had instances running in US West and Europe, these talk to each other. So you do not need to peer these two together, right? These are still within the single VPC and then they can talk to each other. But there are use cases like SaaS services, like a large BUs, right? A large organization having multiple departments. They have their different projects and yet they need some communication to be allowed between cross-project. So that's where you peer VPCs and you peer between projects or across organizations. Now, when you peer, the routes are exchanged between these two VPCs, right? So in this example, VPC Enterprise 1 has a route to the subnets of VPC SaaS via the peering link. Vice versa, VPC SaaS has access to enterprise subnets via the VPC peering link. So now it is the firewall rules that will control which instances talk to which instances.
Right. So this is still internal communication across disparate or separate VPCs, yet you're still able to maintain that fine-grained control using these firewall rules.
Yes, absolutely. And yes, the communication is not going out. It is still within the Google Cloud, and the instances are able to talk to each other using private IP. Keep in mind, though, the firewall rules tables are not exchanged between peers, and this is for security reasons. Your tags also will not be transferred, so you will use subnets as source for your VPC, for the peer VPC. Okay, so we have the firewall rules set up. Next thing we need to know is when you start deploying in cloud, you want visibility, similar to what you have on-prem or other environments. You want to be able to see what is going in and out of your VM. VPC flow logs enables that. It captures all flows at the instance level, so to and from the VM. It is enabled at the subnet level, and then if whenever a flow reaches an instance or flow goes out, be this between VM to VM or a VM talking to on-prem environment or a VM talking to the internet, you're able to capture these flows. Our aggregation is 5 seconds, not in minutes, so it is pretty real time. Some use cases for VPC flow logs is when you're spinning up a new environment, you want to troubleshoot. So you go into flow logs, filter as you need, and you can check whether the flows are working as you expect.
Right. So following this idea of your blueprint, you want to make sure that everything's according to plan, according to your security policies. When you do look at these logs, what kind of information does it actually capture?
It actually captures a rich set of information. So if I take at any of the flow log entry, I will see connection details. So who is my source IP? Who is my destination? Who is it talking to? What ports and protocols I used? And then it'll give me details of the instance that the flow is occurring to or from. So this is my source VM. This is the name. This is the IP, the subnet, VPC, and the project that it lives in. For the source, that is external. It will also give me what ASN is coming from, region and continent details, etc. So it is pretty rich. I can actually take all this information and put it into BigQuery and generate a lot of analytics out of it. I can actually generate a networking dashboard. Who are my top talkers? What is the bandwidth utilization and egress charge, right? So if I see egress by zones, you know how much. If anybody looks at their billing, it's sometimes confusing. This will give you a chart,
right,
and tell you how much egress per zone.
Yeah, and that was going to be my other follow-up question is about exporting these logs. You mentioned BigQuery. If I wanted to export to my CM and correlate these logs with other systems that I'm using, would that be a possibility?
Absolutely. So all of our logs go to Stackdriver Logging. That's our tool for cloud logging. And from here, you have the capability to export it. So you can export to cloud storage. A lot of customers have requirement to store logs for a certain amount of time. So you can just export it to cloud storage and let it be there. Export it to BigQuery. We just talked about it, a lot of rich information. And using our data analytics platform, it also integrates with Data Studio, which is our visualization tool where you can create charts at any time. And you mentioned CM. We can actually stream live using PubSub to any device you want. So a good use case for CM is you want to correlate all the logs in one place. So we have that capability using PubSub.
That's great.
Okay, so now you have your applications front-ended with Global Load Balancer, and you want to scale with it, right? So Global Load Balancer provides us a lot of advantages. So first of all, when you're using your application, use TLS, right? Wherever possible, use TLS. It increases the security, and Google does not charge extra for it. Now, Global Load Balancer is an Anycast WIP, so one WIP advertised globally. So you have one DNS name mapping to one IP. And by virtue of our global infrastructure, here I have an example where I have workloads in US Central, US West, US East, as well as Asia, right? So my customers in Asia can access the application, with a lot less latency than if it were in US West. Now, Global Load Balancer supports auto scaling. What does that mean? If I have a region seeing a lot of traffic and I plan for the capacity, which is good for every day, and then suddenly there are times, right? End of the year, you have sudden spike in traffic. Black Friday, you have sudden spike in traffic. You want your application to be able to handle these. Then the auto scaling feature will be able to auto scale and add instances to absorb that traffic and serve your users. In addition, Global Load Balancer also can do cross-region overflow. So let's say in US East, you're suddenly seeing a lot of traffic, and it may be unexpected, right? But by the time you figure out what's going on, Global Load Balancer is intelligent enough to divert the traffic to the next closest region. So in this case, US Central instances will start picking up the traffic, and your customers will not see downtime, and that's important.
Yeah, that's amazing. And this is all supported, of course, by our large number of points of presence and data centers globally. I see that our CDN is also on this slide as well. How does this fit into this overall picture?
Absolutely. So CDN enables you to cache content at the edge. So you may have frequent requests for certain information. You enable CDN. CDN integrates with load balancer, HTTP, HTTPS load balancer, right? So you enable CDN for your backend service, and it'll start caching content at the edge. So now when requests come in, it'll be served at the edge. Now you just offloaded your backend servers from a lot of requests. Okay, so another solution that we have is Cloud Armor that provides DDoS protection at the edge to your applications. Cloud Armor also integrates with Global Load Balancer. Now we know, right, that instances are protected by firewall rules. Cloud Armor works at the edge to restrict access to the global WIP because the global WIP will have a public IP. This way, here in this example, I have instances at the back end. They are protected by firewall rules. Remember, global load balancers are proxy load balancers. So the source IP is going to be different. It's going to be the load balancer IPs as seen from the instance perspective, right? So that traffic, you want to make sure you only allow the ports and protocols that you want to allow, the traffic you want to allow. Now at the edge, the traffic is coming from a client, right? So that's where Cloud Armor comes in, and you're gonna be having control over which IPs you're gonna allow, right? So in this case, as an example, I'm gonna allow my corporate IPs to access this load balancer. Or I may have specific customers I have this application for, and I'll allow only their IPs. And then I can say deny everything else.
Mm-hmm. So this is sort of speaking to that multi-layered defense where, of course, we provide DDoS protection at the load balancer level, but from the edge, we want to protect from even allowing traffic from those source edge IPs.
Absolutely.
Now, a lot of our customers, I know, also wonder about being able to not only whitelist IPs, but also have the ability to blacklist IPs. Is that something that Cloud Armor would enable?
It can, absolutely. So I have my service open to everyone or who needs to, but I'm seeing, like, you're seeing the logs and you're suddenly seeing traffic from somewhere you don't want. And you're gonna find those IPs and say, I don't want this particular, I don't know, it's not my customer, it's not my corporate, I need to block this IP. So you can add rules to your to your Cloud Armor policy specifically for that IP or a set of IPs and restrict that communication.
Okay, that's great.
So that's a great way to block unwanted
Yeah.
traffic. All right. So here is an example that shows I have my HTTPS global load balancer configured with the backends, and I'm gonna configure Cloud Armor policy. Here my corporate IP range is 50.1.00/16. So I'm gonna add a rule to my policy, allow 50.1.00/16. Now, as you see, employees in San Francisco and Singapore are gonna be able to access the service fine, but you see someone with an IP 120.1.1 is coming in, and that is not your employee, so that traffic will be blocked.
Now, one other question that I start to think about is just the difference between setting up Cloud Armor versus also setting up firewall rules for your specific compute instances.
Yeah. So firewall rules protect the compute instance. So we will look at this example, right? So my user comes in with an IP 50.1.1.5 and has access to the load balancer VIP, right? The load balancer is a proxy load balancer, so it's gonna terminate that connection and open a new connection to the backend. So from my instance perspective, I have the source as the load balancer IP, and the destination is my instance. So the firewall rule will have a source of destination, source of the load balancer IP,
right.
and the port, let's say 443. Please allow this traffic. Anything else, block the traffic. But in this case, if I were not having, so this allowed, but there is no way, my source will always be the load balancer
Right.
IP in this case.
That's
So
going to
how-
remain the same.
Yeah, so how do I protect my front end? So Cloud Armor will come in and say, okay, I'll protect you from the client IPs, right? So that's where I'm saying 50.1.1.0.0/16 is what I'm gonna allow.
Right. And that can vary so much more in terms of like the number of clients that could be trying to access that load balancer.
Yes, this can be globally, right? So
Great.
awesome. All right. So I think let's try to look at some of the configurations of what we talked about, right? We talked about a lot of things. How does it look in Google Cloud Console now? So I have some instances created here. I have a management instance, and I have assigned an external IP to it. Now, if you look at the other instances, they do not have external IP. I can try to go into any one instance, and we will see the configuration. Right, so my instance is in US West 1B zone, has a primary IP, does not have an external IP. I have also added a tag to it saying www, if you remember our previous example. Okay, so now I want to SSH into this instance. So let me SSH here. So I'm going to go into my management instance, and from there I can access all the instances. I also have some instance groups here. So we're going to walk through a global load balancer setup. My instance groups will also have the same tag. So my template should have the tags that I want to have. Okay, so here I am. Now I want to SSH into 10.2.1.2. So this is my internal instance, right? So remember, I want to be able to go out to get updates, etc. So I want external reachability. So how do I do that, right? So I need to add CloudNet, as we had discussed earlier. So to be able to find CloudNet, you go under Products, Networking, Network Services, CloudNet. And I have a NAT gateway configured already. We'll just go through the configuration. This is in my VPC and the region US West 1. That's where my instances are. And here I'm saying all subnets, primary and secondary, will be able to access my CloudNet. I do have an option to say specific subnets, right? So here I can say custom range, and then I will say only my demo, my web servers will be able to go out, right? Things like that. So I have the option of doing that. I can also say only primary ranges. Subnets can have secondary ranges, but you may not want those to go out. So you have control like that. I already have a gateway connected. So let's go to my instance and let's see if we are able to go out. Yep, without a public IP, I am able to go out. So that's pretty neat. Now let's look at our load balancer setup. So this was my NAT setup. We already saw this. We talked about VPC flow logs. So I just want to walk through one of the entry, how it looks and what information you're able to see. So we did SSH. I am able to, this is our Stackdriver logging screen. I am able to filter. So here I want to see who all SSH'd into my instance, right? So I will say destination port 22 and the IP of the instance that I want to look into. And here is a typical entry. So I have connection details, the destination, the source. In this case, this is my management VM, and the destination port is 22. So I know there was an SSH action. Then these are the details on the destination instance. It tells me the instance name and the region and the project that the instance lives in. And of course, there's a timestamp, and then there is a source instance details. If the source is within VPC, you'll find similar instance details. If it is external, it will give you more details on the origin of the user. Perfect. It also tells me reporter is destination. That means the flow is to my VM in this case. All right, now let's quickly take a look at the global load balancer setup. So I have a load balancer setup, I have a global WIP, and I have HTTPS enabled, and I will have a backend to it. Now, I also have a CloudArmor policy configured here. So go to network security and CloudArmor, and then I have a policy that will allow to everyone, but I know I don't want to allow specific ranges. So I will have one deny policy, and then I am okay to allow to my corporate. In this case, I've allowed to the rest of the world. I can go in, this is my last rule, is my default rule. I can go in and set it to deny. If I do deny, I do have options to configure what kind of response the user will see. So it can be 403, 404, or 502. So you have the flexibility of configuring that.
So I see here, this is how you whitelist versus blacklist certain IP ranges.
Absolutely. Now let's look at some of the logs here. So I am gonna try to send this one request to the user, and I am able to see because I have actually opened it up to the world. Now if I look at any one particular log, entry, you will go into HTTP load balancer, and then you see enforce security policy. So it will tell you this rule hit which policy rule, right? This flow hit which policy rule. So in this case, the security policy was configured to accept. The name of the policy was CloudArmor policy GLB HTTPS, and the outcome was accept. Now I could have had a deny here, and it will show me which policy was triggered. And here is the detail of the forwarding rule that was tried to access, and then the zone configuration. All right. That's all I had.
Great, thank you. I think it was really nice to see it visually in terms of the flow logs between either hitting the load balancer versus your specific instances in the backend.
Yes, it is actually, I would highly encourage you, just go to Google Cloud and look at these options. CloudArmor sits under network security, CloudNet, load balancing under networking services.
Yeah, I see it's giving a lot of options for reducing that attack surface by preventing you from always having any of your instances open to the public. So there's a lot of options here to protect your VMs.
And keep checking, we have a lot more features coming
That's great.
out, so yeah.
Well, thank you so much. We do have a couple of minutes to just collect some questions, and we'll just be back in a minute, and we'll try to answer some of them.
Sure.
All right, welcome back. We have a few questions that we'd love to get answered for you all that we've just collected. The first one, which is, can I enforce firewall rules for other services like App Engine?
So you can. App Engine firewalls use the same firewall rules table. So firewall rules work for GCE, GKE App Engines.
Okay, great. And the next question is, can I control communication between two subnets using a third-party firewall?
So this is a good question. So when you say two subnets within a VPC, when you create subnets, these are local subnets, and there will always be a local route generated for that. So if I want to go to subnet 1, VPC 1, to subnet 2, VPC 2, VPC 1, it's going to be the locally generated route. So this communication cannot go to a next hop, external next hop, and come back. However, between two VPCs. So a good use case for a third-party firewall is you have multiple VPCs and you want to see communication between these two VPCs. That's when you use a third-party firewall. You spin up an instance with multi-NIC, and you can have one NIC in each VPCs. And that way, your next hop, so when you want to communicate with subnet 1 in VPC 1, with subnet 1 in VPC 2, you can configure the next hop as the third-party firewall, and your communication will go through the firewall, so the firewall gets the visibility it needs to get.
Okay, so there's two things there. You can set up multiple NICs on a single VM, and then also that if you are using two subnets in the same VPC, those are actually using local routes, which is why you wouldn't be
Yes.
able to use a third-party firewall in
Yes.
that case.
Yeah, so even if you add a route can have priorities, right? Even if you add a route with a lower priority for two subnets within the same VPC, that route is going to be disabled. The local
Right.
route will always be
I see.
preferred. I do want to go back to your point for third-party firewalls. Yes, you can. You need to use a multi-NIC VM. So a typical use case for third-party firewall is you have an outside interface, and then you have at least one inside interface. So you can have a multi-NIC VM with up to 8 interfaces, and then you have the inside configured, and then the outside VPC. So the instance has a leg in each,
Right.
and then the firewall controls the
I
communication.
see. Okay. Our next question is, can I log firewall rule activity, which I think we might have covered in the presentation, but yes.
Actually, yes, you can log firewall rules activity. So for each rule, there's an option. You can enable logging, right? So all connections, now this is not sampled, all connections will be logged.
I see. Okay.
So it's a good use case for troubleshooting. Also, when you suspect something is going on, you can start logging.
Yeah, so you want to measure and keep a log of whether or not things were accessed and whether those firewall rules were being used.
And again, these logs go into our Stackdriver logging. So you are able to see it there as well as export it to wherever you want.
Okay, our next question here is, when I block traffic using CloudArmor, what response code or message does the user receive?
So when you configure a rule to deny, you have the option to configure what is the message the user will see. You can configure a 404 error, 502, or you can say forbidden, so 403.
Okay, and I think we saw that in your demo as well, that you get that drop down.
that's true.
And our last one is, can you elaborate on how you control traffic between projects that are using a shared VPC?
Yeah, so shared VPC is a way to scale with larger organizations, right? Typically on-prem, you see you have network and security functions. So you have network admins, security admins, and then there are application web admins, right? Web admins don't necessarily spin up subnets and add firewall rules, a network admin needs to have control over the the IPs that are being used across projects, the security rules that are being added. So shared VPC enables that. So your networking and security function is centralized in the host project. That's where the VPC lives. Now that VPC you share with different projects, service projects. So these other projects like web projects, you connect to the host VPC, and they're called service projects. So as you share subnets with these service projects, the compute admin over there will be able to spin up instances, but not add firewall rules. So the firewall rules function still stays in the host project, and you still use firewall rules to do that.
Okay, so you do use firewall rules even if you are using a shared VPC.
Yes, it is a single VPC still, right? It is one VPC, and you still use the firewall rules just the way you use with other VPCs.
Great. All right, so I think that's all the questions that we have. Thank you so much, Manal, again, for giving us this deep dive on security best practices. I've truly enjoyed going, more in depth about security and networking.
Thank you very much.
Yeah, thank you so much. So please, again, stay tuned. We do have more sessions coming up today for Cloud on Air. Our next one is Power Innovation for SAP with Google Cloud. So stick around. Thanks again.
Thank you.